Hi everyone, it's Has, and today we are going to continue with our videos about Patran Nastran, and we are going to simulate a road, that is, how to say, constrained in one side and then applied upon by force in other side. So this is our exercise. So we have this road and then only just a beam, but we are going to modelize it as a rod in our software as it's a traction force, right? It's a traction. But if it's a flexion, maybe or no, if it's a flexion, as going to need some deformation, by the flexion. So we are going to put some cross section and modelize a real beam. But as long as it's traction, we can go with the rod. It will work. So what I'm going to do is first of all to open a new file. So new here, we are going to save it, YouTube Patran Nastran, and then we give a name. So the name is, let's say, a road or a road. Let's say a road. So okay, right here, and first of all, let's go to geometry, right? So we're going to start at geometry, but before we are going to have this window, right? So everything is okay. Good. Now let's go here. Yeah. Now we go to geometry. So first of all, let's go to here. The first point, let's deselect here, unselect here, because we need to control ourselves. If you have auto select, it will auto execute, it will create things automatically, but we don't want to have that, right? So apply. So we already applied the first point. We are not able to see because we need to display. So let's go to home and then L and click on this point. We can see point 1. Let's go and check the length. The length is 2 meter. So we are going to work on meter. That means all of these, we are going to apply them on gigapascal. This because if you have meter, you need to work on gigapascal, right? But if you have millimeter, you will work on no. If you have meter, you are going to use it as gigapascal, as I said. But if you have it as millimeter, you are going to apply it as megapascal. So it's up to you to choose. So me, I am going to work on millimeter. So these young modulus, I'm going to apply as megapascal. But here I have the density in kilogram per meter cube. So I think I'm going to stick with the meter because I don't want to convert everything, right? So 2. So point 2, let me just put 2 in here and then apply. This is our point 2. And then create curve. I'm going to unselect here. So starting point is 1 and ending point is 2, and then apply. We have our curve. So now we finish with the geometry. Now let's go to meshing. That's where we are going to mesh our model, right? So first of all, create mesh seed. So here we are going to, let's unselect here, we are going to define the number of elements we are going to use. As this is a rod, so we are going to apply only one element. Why is this? It's because the displacement is constant in the rod, and also the stress is linear. So we don't need to have more elements for it. So the curve is going to be this curve, then apply. So now already define our element. We have only one element. We can see here, mesh seed create. And also now we are going to mesh. So let's go create mesh. And then here we are going to change surface into curve. And here we are going to choose this curve and apply. So we can see here one element created. So now we're fine. Let's go to loads boundary conditions. So here we are going to apply our boundary conditions. Let's see again, we have a totally fixed support in here, and then you have an applied force in here. It's a traction along the horizontal axis, right? And the value is 30,000 decanewton. So we are going to apply the fixed support first. Let's say fixed support. We give a name, fixed support, fixed port, and then input data. So for a fixed port, that means all the translations are blocked. So 000, and now all the rotations, right? 000, then okay, select application region. Where do we want to apply the fixed support? It's at point 1, and then add, and then okay, apply. We can see 1, 2, 3, 4, 5, 6. So 1, 2, 3 represent all the translations. 4, 5, 6 represent all the rotations. Okay, so now let's go to apply our force. So we change the displacement and then force. So now let's give a name, traction force or traction. Okay, so now let's go to input data. So it's gonna be along the x-axis. So it's 30,000 decanewtons. So it's 100,000 newton, right? So now 0 on y and z, and okay. Select application region is going to be applied at point 2, add, okay, then apply. So here we apply our force. Now let's go to material. So here we are creating our material. So it is steel, and then input properties. We give Young modulus. So the Young modulus is going to be 200, no, I think 2E09. So this is gigapascal, okay? And then we have cohesion ratio, 0.3, and then density. Let me check the density again. 7,800. So now we're good. Okay, and then apply. We can see here the steel is created. We can also come out here, material creates. So now we're fine. Now let's go to apply our material. So it's going to be on properties. And then we are on 1D, right? This is a one-dimensional problem. So let's go to 1D. And here we change the beam into rods. Okay, now we give a name, property, and then we go to input properties. Material name, we already have material, so we click here, steel, we choose it. Now the area, so the area is going to be 496E minus 6, so it's 10 power minus 6 millimeter square. Okay, so now okay, here application region, where do we want to apply it? At curve 1. We can also type curve 1 here like that. It's going to work. Okay, now let's go again. Yeah, we add it, so we can see here the color changing. That means it's being applied. Okay, apply. So here material set property created. So now load cases, we already have a one load case, so we don't need to go there and manage the load cases. So now let's go to analysis. But if you guys really want to know how to manage load cases, you can comment below so I can show you the way you do it on a different tutorial. So let's go to analyze directly. So on analysis, we can go and set up this simulation, right? Let's go first, solution type. We are on linear static, so it's okay. Solution parameter, we're good. So yeah, everything here is good. We don't need to change anything here. Let's go to subcase. Subcase, we already have only one case, so we have on default. We can go on output request. Output request, it's where we tell our software to calculate what we need. Here we already have default output request already created. We have displacement. So the software is going to calculate the displacement, the stress, and force. But I also want to see the deformation. So the deformation is the strain. So here is element strain. Let me add it. So I click on it. So it's being applied in here. So we are going to have results about deformation as well. So now the other ones, we don't really need them. But if you want, you can add all of them. fatigue life, and all the stuff. So now let's go to OK, apply. Here is apply. So let's close it and then apply in here. And now automatic calculation is being done by the software. So we are going to wait and see the results. Okay. So it should take few seconds because it's not a really loaded exercise. So now it's finished. So now let's change analyze in here and go accept results. So let's go and select our results file. So it's rod H5, so we click on it, okay, and then apply. So here, attach result file. So the result file is being attached. So now we can have access on our results. Let's go to results, and then we have it in here. What do you want to see? First, I want to see the displacement. So I click displacement translational here, translational as well. Apply. We can see here. We can see in here. Let's see. Let's do this. Yeah, we can see the displacement in here. And then we want to see the strain as well. Apply. We can see the strain. Strain is deformation in French. Deformation, So this is strain. But in English, I think deformation can mean displacement, right? But in French, because I'm French, so deformation, it's like deformation in French, it's really different. But let's say the strain. I think you guys understand what strains mean. So now let's go to the stress. The very important factor is the stress. Apply, we can see in here, right? But this is in gigapascal, okay? So in megapascal, so this is in gigapascal. So we have it as 6.05 10 power 8. So this is the end of our tutorial. So that's how you do a simulation on Patran Nastran. So I hope you enjoyed it, guys. Peace.